For my teacher strategy presentation, I decided to create a Google Slides document. Google Slides are something that I use in my classroom a lot, pretty much every day. Anytime we are doing anything or I give any direction, I have it up on the board in a Google Slide so students can listen to what I'm saying as well as read the direction, question, activity on the board. So if I were to do this activity or lesson in my classroom, this Google Slide is exactly what I would use as I'm walking the students through the activities. As I started to create this lesson, I'm realizing that this is probably something that would be done over multiple days instead of just one day. My strategy was model-based inquiry. My anchoring phenomenon would be space, and specifically the moon and the earth. I would start my lesson by asking some questions to the students just to get them thinking, nothing that necessarily relates to science, but just to get them interested. So I would start with, do you know any twins? Are they identical? How do you know? What does it mean if something or someone is identical? Students would probably say they look exactly alike, or there's twins in our class and they look the same. Their parents told us they were identical. I then would ask them to look around the room and see if they could find anything that is identical, and how do you know? Maybe the desks, the carpet tiles, the chairs, and they could explain how they know. Do you think there's anything in the environment that is identical? Flowers, trees, rocks. What does it mean if something is genetically identical? Students might say genetic makeup is the same. What it is made out of is the same. I would then give the example, if cookies are genetically identical, what does that mean? It means they have the same ingredients. They are made of the exact same things. I next would prompt the students with this question. Do you think the moon and earth could be genetically identical? I would have them turn and talk to a partner and share their ideas. Model-based inquiry is based on the students' ideas. It revolves around their ideas and what they are sharing. So I would allow their ideas to kind of guide my unit and take what they say and go with that. My next question would be the big science question that we are going to solve. Why are the Earth and Moon genetically identical? The students might have given many reasons about, yeah, I think they are, but now we're going to address the why. I would split the students into small groups. They probably are already in small groups in their table groups or partners. I would pass out a plain sheet of paper and poster paper. On a blank sheet of paper, I would have the students jot down anything them and their group are thinking when they hear the science question that we are addressing. Why are the moon and earth genetically identical? What are their initial thoughts, ideas, questions, answers to the question? When I asked that question, what popped into their mind? Just initial thoughts about the first things. With those ideas, we would do a chalk walk. The students in their group would now hopefully have a huge list of questions, ideas, statements, answers, and I would want them to choose one of those, their favorite, best question or statement, to write largely on a piece of poster paper. The students would then participate in the chalk walk. There would be no talking, and the students would walk around the room and respond to the questions or statements on the poster. They don't have to sign their name, so this is a great way to get everyone involved in the activity and responding without calling people out if students are embarrassed or things like that. After the students have responded to a class we would have a class discussion on the chosen questions and statements, why they chose those, and how people responded. The next activity in this lesson would be to read an article. We would read part 1 on the genetics of the Earth and Moon. Before reading, I would tell the students that they are going to draw a model to represent their thinking. Part 1 I have attached here, but it basically describes how scientists for many years have believed and know that the Earth and the Moon are identical. But they have many different theories for why the Moon and Earth are identical. That would lead us into our model number 1. Students would work with a group to create a model on how they think the moon was created, why they think, what they think happened to make the moon and the earth essentially identical. They would choose one color, they would use captions and pictures, be very detailed. Remember, this model 1 is only the first one, so it's okay if it's not correct. While the students are working, I would walk around and participate in discussions and conferences to hear students' ideas. The next thing we would do is we would read the next section of the article. This provides students with ideas, some of those ideas that the scientists think about the moon and the earth. So this would kind of give them ideas. I did not have them read this part during Model 1 because I wanted them to kind of think on their own. After we have read some of those ideas from the scientist, they would choose either one of those ideas or one of their own ideas to explain why the moon and earth are genetically identical. I would want the students to find as much evidence as they can to support their idea. Once they're done researching, they will edit their first model. This should say Model 2. After they have done the research, they're going to edit Model 1. Model 1, they did an all one color. They're now going to use a second color and make changes to Model 1. It could have been completely wrong. They're going to make changes. It's going to be messy. Again, during this time, I will be walking around asking questions, listening, providing feedback, and observing students' thinking. After students have completed Model 2, they're going to do a little bit of peer conferencing. The groups are going to rotate around the room and conference with a few other groups. They're going to share their models, their findings, compare and contrast the models of the two groups, and maybe, wow, my group thought this in Model 1, then we researched, got some evidence, and now we know this. They're going to collaborate, share their ideas. After peer conferencing, I'm going to ask them to create a final model and explanation. Now that you have made predictions, had discussions, read an article, created 2 models, and done research, you will now create a final model to answer the question, why are Earth and the moon genetically identical? They're going to create a detailed model using pictures and words on another piece of blank paper. They're going to use Model 1 and 2 as a resource. They're also going to create a written explanation to explain their findings. Then they're going to come up with a way to present their model and explanation. It can be anything, a skit, a Google slide. They can hold up their piece of paper and just talk whatever they want. I provided the students with blank pieces of paper because I wanted them to demonstrate and express themselves with their model however they wanted. I didn't want to give them a cookie cutter way. I wanted them to be able to put their ideas on paper in whatever way worked best for them. The final thing that we would do in this lesson is a reflection. I would have the students fill out a Google form reflecting back on this lesson. What did they learn? What do they still wonder? What do they have questions about? What did they learn about model-based inquiry strategy? What do they like, dislike? If I did this activity with another class, what should I change? I'll have the students do this on a Google form, but if any of them want to share out these answers, we can do that as well. I hope you enjoyed my lesson.